Bugly. I checked out the definition this morning. It actually means but ugly. So, but I had it as buggy and ugly. But what I want to do is just share a hard truth with you all, is that fundamentally we build extremely bugly web applications. And we as in you. And there's many reasons for it. One is login is so complicated, so we build a big fortress and put applications behind it and features behind it, and because it provides some sort of sense of security, we go from building apps really to building really large fortresses. You know, you go through this big gate, this moat, this security gate, and then all of a sudden you've got access to everything. That creates an extremely slow, archaic, large, wannabe web application, which is really a website with a whole bunch of proprietary glut inside it. They're expensive, extremely expensive. And as an architect at ING, we have this discussion all the time. We want to refactor, but refactoring comes at an extreme cost. We want to move from one framework to another, and it requires such a big move that we end up having really a Frankenstein of frameworks, many of them. It's not really this and it's not really that. Also, it's extremely slow because it's so large. And if you take a look at the websites that are being built today, and even the ones that already exist, they're extremely large and disruptive. So it's not good news. Actually, it's so bad that there are people in the community that actually have websites that track your websites. One, for example, is AussieOutages.com. This is a community where they're monitoring the availability of websites and essentially the bad experience of websites in the finance industry. And the top 4 banks in Australia collectively only offer 91% availability. That's 33 days where they're out in a certain year. 33 days you can't bank in the country. That's scary, right? 33 days, it's huge. And the best part of it all is that they tell their customers on Twitter, hey, guess what, we're knocked out for the weekend, so plan ahead. God help you if you get a date or something like that, you're in trouble because, sorry, baby, I just got $40. So this is part of the problem, and it's almost like it's okay. It's almost like, it's all right, we're using jQuery, it's fine. It's okay because we're using Redux or whatever, or we're using Ember or something like that. And what I'm trying to highlight is that all of that largely is fundamentally, from a business point of view, irrelevant. But if you take a look at the growth in the transfer size, you'll see that most of our applications and essentially our pages are growing dramatically. There's an organization called HTTP Archive who actually trends this stuff, believe it or not. There are people that actually find this stuff fascinating. And the size of a page now, a total transfer for a page, because these aren't single page applications, is the same size as Doom, the game. Who played Doom? I know you all played Doom. All right? And Doom ships with its own 3D rendering engine, believe it or not. It has its own weapons and a whole bunch of stuff, and there's some really good nuggets and Easter eggs inside it. All of that is actually 2.4 meg. That's the size of a page that we're downloading today. Every time a customer goes to a banking application, or any application, to be honest with you, because if you take a look at these guys, that's what they're saying, it's a Doom every time. Strange. But that's okay, guess what? There's Moore's Law. If we can't fix it, CPUs will. It's okay, the customer will get a new phone, it'll go faster on their phone. And actually, there is some science to it, there is some truth behind it, because as you can see here, some organizations have been publishing benchmarks for the new iPhone 7, and it does perform extremely well. But for every law, there's an anti-law. And Worth's law, I think some people say it's Page's law and Gates's law, I don't think we'll ever know, fundamentally saying that the software efficiency due to codecraft, featureitis, a whole bunch of other stuff, halves every 18 months anyway. Actually, there's another reason. It's fundamentally because we build applications to build our resumes. What we do is, like bubblegum, we go and we say, okay, here's a new framework, I'll chew on that for a while. And when the taste goes, I need a new one. I'll get a new job with someone else and leave this big application here. Yes? Yes. And so what happens is we end up with this big, fat, monolithic monster in an organization that the new developer looks at it and goes, I need a framework. Note the loop. And it obviously ends up having excessive refactoring. We have a Frankenstein of proprietary, opinionated implementations. It's extremely not shareable. It's siloed. It's a mess. And fundamentally, let's be honest, as front-end developers, there's a law called Conway's Law, and I'm sure you all know it. We all read it all the time. But basically says the communication channels of the organization will fundamentally reflect in your application. Yes, we try to solve everything in the front end. So the front end gets bigger, more frameworks, and blah, blah, blah. But when we talk about architecture, fundamentally, we're talking about code organization. Whether it's MVC or something else, we're always talking about code organization. But the unit of change is still the application. Mergers are expensive, they're difficult to share, it's extremely complex, the composition is difficult, and we end up with a mess. So let me give you a real example. Let's take 4 scenarios, banking scenarios: account opening, move money, bills, and transactions. The company says, okay, we want to do a project on move money. That's okay. So we do an assessment. We take a look at the channels, the front ends. We take a look at some of our services. We take a look at the core at the back end. Then possibly we take a look at some platforms and some operating systems. And we come up with, yeah, this is an approach. We're going to do it this way. But what we discover, which we all knew, is that the core makes assumptions about platforms. The services make assumptions about the core. And then the channels make assumptions about the services. And fundamentally, we have a really big project. That's okay if you're doing one. The problem is when they want to do the bills project. And when they want to do the bills project, there's a lot of contention, bottlenecks, and ultimatums that have to be made, and essentially 1 + 1 ends up equaling 3. That's why it's not just fundamentally an estimation problem, because we all say, hey, you can't estimate development. Okay, you can't estimate, but also accept the fact that we have crap. And because of crap on crap makes a very big and difficult way to estimate. So the last part of this tragic story fundamentally is an event happens, whatever it is. It could be a new framework, such and such, and then a hero pops up and says, great idea, let's adopt another framework. I'm going to build a modular framework, which Dr. Carlos Brown, in a book called Design Rules, actually did one of the biggest assessments on modularity, and fundamentally came to the conclusion that we all intend modularity, but it's really a monolith. And then we end up going with different opinions, because as time progresses, we end up adopting different opinions. It becomes buggy, and then we wait for the new event. And that new event typically is when the developer leaves. Or a new framework comes out, and then it becomes really, really fast. So is the problem the languages, or is the problem the platform? And as Sir Alex Russell says, the problem is fundamentally about the platform. And I'd like to add it's also the people. So the web needs you. The web needs you to get serious about being a web developer. And fundamentally, what does it mean? What does web mean? It actually means that you're a standards-based developer. So you need to take a look at new use cases, and once you find new use cases, work with those new use cases, and basically converge on certain agreements on what those primitives could look like, and also abstract them out so that we can start using them with polyfills or something like that. And then when the industry body sees and understands the value we create, they move them into primitives and into standards. But we have to let go and go to the next one, not continually fight over and over again. And the things like the Extensibility Web Manifesto is actually starting to do that and promote that type of language and that type of thinking. So what does it mean? It means that true beauty is on the inside. It's not just about how it looks, but also about deep inside how it works. It has to be performant. So at ING, we take Google Rails seriously. So serious, it's actually become the criteria for our non-functional requirements. Yeah? So we now have very specific criteria that the responses have to happen within 100 milliseconds. applications have to be less than 1 meg. They need to be secure. I won't go through the security standards, but what I will do is this. Guys, securityheaders.io. Scan your websites and take a look. If you don't get an F, you'd be surprised. Seriously. Banking sites, most of them, and I've scanned most of them, score an F. An F could mean a few things depending on how you take it. Also build your applications to be immortal. And what we mean by immortal is that it's not just that it's bulletproof in the sense that it never dies, but it's also long-living. So adopt and embrace standards. Use the platform for what it is. Push the state to the client, not in the server. Because the ultimate state is the user. Build offline first. Unplug your cables, turn off your Wi-Fis, and build like that. And try to make sure it works offline first. Handle failures. And go with the progressive applications. But also, when you're going with modularity, understand that we want it. What does modularity mean? It means that we have to make it design time independent, that I can work on this thing independently of the whole. But at runtime, it's got to work interoperably. So it frees me at design time, but at runtime, it works really well as a member of the wider community of components. So now the unit of change is the component. It's not the application, it's the component. And when the component is the unit of change, we assemble applications based on components. We don't develop applications anymore. We develop components. And from those components, we can assemble very different business functions. For example, at ING, we say that the customer service team that answer phone calls need to see the same experience that the customer sees on their mobile or on the web. To me, it sounds like sharing components. Yeah? The only difference is one component is embedded with a telephony, with telephony features so that they can answer phones, but the other is not. So our definition of done. This is what we put down as a quality criteria for a component. Every component in the bank must have its own repo. It must have its own life cycle, and it has its own repository. It's built with internationalization out of the box. It's built with accessibility out of the box. We no longer debate whether those who have partial vision or vision impaired are some sort of subclass customer. We expect it to be accessibility compliant day one. Also, the tests are baked in day one. The thing works. There's even a demo. And I would go so far as to say that we need to move towards some sort of demonstration-driven development, not just test-driven development. Get the demo in the hands of the developers as quickly as possible. Show your stuff works. We've even gone so far as using blueprints to mock the APIs at the back so that custom elements now have a one-to-one relationship with APIs. And we've actually produced the documentation. And this is clear criteria for what we call ready-based components for consumption by the next developer. So when we take a look at the architecture, most banks and organizations were or are still, unfortunately, in the big blue box. And some are having discussions about moving towards a client-server-based mainframe, still back-end database scenario. And the rest of the world is stuck in this hole now, where they're taking a look at the middleware and APIs and SOA and having discussions about microservices, etc. But we see an opportunity. We see that the opportunity is potentially, we see the microservice movement, but at ING, we've gone one step further. We've predicted that the world will fragment even further, and our architecture needs to look like that. We want to have custom elements with domain-based services at the back. And those domain-based services can be part of that custom element scope. And now it means when you ship a custom element to another team, it also comes with its APIs. Not only the APIs for component interaction, but also API for back-end interaction. It goes a little bit further. We also have to take a look at the way we do APIs, because we want to minimize the number of chattiness between components and backends. So our responses are now rich responses. And it means that when I move money, I also get the balance back and the list of accounts. So I don't have to do subsequent calls to get, hey, what's the new balance and what is the latest accounts of the customer? Now, with the response, I can do some data binding and then publish the new balance to all the components that need it. And it fundamentally means 50% less I/O, but it also means I now get to use data binding the way it should be used. So how does it look? It's a technical summit, so let's talk about it. Fundamentally, we produce the APIs automatically because we have mocks and interfaces. We have them very clean, we know what they are, and we now have an outside-in model where we work with our business and say, what do you want? The API is not driving the application or the component, the requirements of the business, and the user is driving the API. And we generate the APIs because, let's be honest, it takes forever to wait for a back-end person to give you an API. Yeah? So stuff it, we just build it ourselves. Conway's Law. And when we get the APIs, the response from the API is very simple. We update the variables in our store, and you can see they're all custom elements, and the data binding then becomes available to all the components that are listening. And the process repeats itself over and over again. And if you notice, the actual system is extremely simple. It's so simple that when you think about it, it's actually an end-to-end working system of a collection of components. Our entire digital front end, particularly in ING, if we take a look at the Australian scenario, is completely web components and custom elements. There's nothing else. There's no frameworks, there's no additional libraries, etc., etc. It's fundamentally just a whole bunch of custom elements. And we use BFF, which is backends for front ends, in order to abstract those APIs and make them bound to the custom elements. But what's important is that our APIs are not cattle. We're not stressed about the APIs themselves. That way you have interface and contract-based experiences. The APIs fundamentally reflect what the customer requirement is. So they're not pets, sorry, they're cattle. APIs fulfill the demand of the experience, and we come to the understanding and the agreement that poor backends also equal poor front ends. So you have to fix your backends as well. You can put a nice custom element in front of a system and give that in the hands of the customer, but if your backends are crap, then your front ends are crap. So, believe it or not, I've heard Taylor and Matt say over and over again, there's an element for that, there's an element for that. Well, at ING there is. There's 350 of them that are being used, and our friends all over the world, including the Netherlands and Germany and Belgium, etc., are building custom elements for the group to use over and over again. The number of APIs we have that are being used, honestly, I've lost count, and to be honest, I really don't care. So long as it returns the data that I need and it's bound to the custom element, we're fine. If you take a look at it, every application that you build at the front end needs some visual components, some rich visuals, some navigation, utilities, and customer features. Most of those we want to source from the market. We don't want to build everything ourselves. Whether it's a telephony component with Twilio or it's a charting component with Varden, it doesn't matter. If it's available in the market, go get it. Ship it as a custom element, and we will build the pieces that are in the gaps, the stuff that's specific to us, banking. So we're assemblers first, and that's the key message. We are assemblers first. Being an assembler means go into the box of Lego, find the Lego piece you need, and then put it together. Don't go build your own. And most developers love file new. And we need to move away from file new and go into the box and go to the repos and find one that makes sense. Read the markdowns. There's a reason why we've written them. And we're craftspeople second. If they're not there, then we craft. So what does it look like at runtime? Well, fundamentally, we have single-page application that's HTML5, and we have two files. Our entire application is two files, index.html and ing.js. Only data ever traverses the network, so all you ever see when you look up the network, you see the XHRs just going across. State is centrally managed and into the client, and all the business logic, what constitutes business logic, is in the back in the data center. And there's a reason, because data centers have 40 gigabits per second networks. So we push all the service aggregation and service composition into the data center where it's faster. So the front end is extremely light and extremely thin. So you need to break Conway's Law a little bit and have a conversation with the people in the back. And if they don't want to respond, then do it yourself. What does our runtime metrics look like? We've been working with Polymer since 0.5, and we love it. And when 1.0 came out, we were ecstatic. And now in its current state, this is what it looks like running at runtime. The industry average, if you look at GT metrics for page speed, is 81%. ING is at 98%. Our page load, industry average is at 5.8. We're at 2.3. And that's not good enough, as you know from the Google Rail discussion. Our page size, the industry average you heard earlier, is the size of Doom. Ours is 538 kilobytes. That's the whole app. That's everything. And the request, the industry average for requests, believe it or not, is 69. And with HTTP 1, it's actually at 2, so it becomes even worse in terms of serial requests. And ING, it's 9. So now what does that mean? Let's go back to this scenario. When we do move money, and we do the transactions project, they're not coinciding and they're not contending for resources. Bills can also go in parallel as well and have more concurrent development. In fact, we can have a lot of concurrent development because the architecture is broken up. We don't have a monolith per se. But the real advantage of all this is that we have a culture of motivation. People are autonomous because they can do it inside their component. They have purpose because they know they're working to a business end and a business goal. And they're also masters of their domain because they can use the right technology for the right function. But why web components? I get this question a lot. ING bet on web components really early. Apple said something along the lines that they are the web. Standards are the web. Yes, there's lifespan benefits. There's parallel delivery, as I said earlier, time avoided. There's also the value of business options, the fact that you can mix and match. And imagine what scenarios you could do if you can take one component into another business stream. But really, from my side, I actually want to talk about the facts. Again, the Polymer team have been saying over and over again that use the platform, use the platform, use the platform. So we went to GitHub and counted the lines of code. Thankfully, they actually offer a function that does that. And I think the chart speaks for itself. There's 4 times more markup with Polymer than any of the other frameworks that are available. And there's 10 times less JavaScript. This is over 3 years, 3 years since the inception of Polymer. That tells you volumes. If you want to be a JavaScript developer and you want to solve platform problems with JavaScript, you will have a problem with Polymer. But if you want to solve true customer problems with the web, then Polymer is your choice. So final slides, learning and unlearning. What we found is more people are framework developers than they are actually web developers, so we had to teach them HTML5 again. Sorry, but it's the truth. They don't know what a media query is, we don't know what sections are, and so on and so forth. Also, you need to build a lot of automation with your tool chains to make their lives a little bit easier. You need to offer samples and guides, but probably the most important thing is get them to assemble something first. Not craft something, assemble. Build their first component second, and then finally, evolve it if you can't solve it. Thank you.